We're going to be looking at interest-only loans. So interest-only loans, which the name kind of suggests, are loans where the borrower takes out a certain amount of money, like with any other loan, but when they make repayments, they just make repayments that are equal to the interest on the loan. So what that means is that the balance of the loan actually stays the same each time period. So the balance of the loan doesn't get brought down gradually over time. It actually stays the same over time because each month or each quarter or whatever the time period is, the person who's borrowed the money is just paying back the bank the interest on the loan, and that's it. So the balance of the loan doesn't go up, it doesn't go down, it just stays the same over time. That's what an interest-only loan is. Interest-only loans can be I guess we've got a formula that we can use for interest-only loans to work out what the repayment amount is going to be each month or each quarter or each week. And that formula is as follows. P equals V0 times R over 100, where P is the repayment amount. V0, as always, is the initial amount, in this case the initial amount borrowed, which we call the principal sometimes. And R is the interest rate per compounding period as a percentage. So that formula gets used to work out what the repayment on an interest-only loan would be each time period. Let's have a look at an example of how it works. So in example D1, we've got a person, Naya, who wants to invest $40,000 in shares, and she takes out an interest-only loan at 6.9% per annum, compounded monthly. We have to calculate the size of Naya's monthly repayments. So I guess the first thing to look at is picking out the information in the question. So we know that our interest rate is 6.9% per annum, but when it's compounded monthly, like with recurrence relations, in this formula we have to adjust that rate. We have to divide it by 12. And so 6.9 divided by 12, got the calculator over here, is going to give us 0.575%. Okay, so that's our monthly interest rate. Then the next thing to look at is, okay, well, what's the payment going to equal? And the payment is equal to V0, so 40,000, times R divided by 100. Okay, so this line of working here is just using the formula from the previous slide to work out the payment size. So $40,000 times 0.575 over 100, and that will give us times, let's get that fraction there, 0.575 over 100 equals 230. So the payment size each month is $230. So that just means that over the course of this loan, that every month Naya would be repaying $230, which is equal to the interest on the balance each month. All right, next example, similar kind of question, but this one's got two parts to it. So this time we've got Pete, who wants to take out an interest-only loan to purchase some artwork, which he believes will increase in value. His bank offers him an interest rate of 6% per annum. Okay, so part A of the question says he decides that he can afford to make quarterly repayments of $500, and we have to work out how much he'll be able to borrow. Okay, so this question's a little bit different, I guess, because when you look carefully at the information that we have, we know the interest rate, but this time we actually know the value of the payment. What we're trying to work out is how much could he actually borrow to begin with. So we can still use the same idea, I guess, of firstly dividing the interest rate by 4 because it's quarterly. So again, on the calculator, we can chuck that in. That'll give us 1.5% as our quarterly interest rate, 1.5% per quarter. And we can also still use this same formula, this payment equals V0 times R over 100. But this time, the numbers that we know are the R and the P, right? We know the payment and we know the interest rate. So we can put those in. 500 equals V0 times 1.5 over 100. So I guess the thing that we're looking for now is to solve for this V0 because that's how much you'll be able to borrow at the beginning. So essentially we need to do this as a solve. And remember that on the CAS we can do that pretty easily. Action, advance, solve. And our equation is 500 equals V0 is the unknown, so let's just use X for that number, times 1.5 over 100. And because we've used X, calculator is going to, by default, try to solve for X. And we get 33,333.3333. And remember that because this is an amount of money, we'll round it to 2 decimal places. And so the amount that he can borrow at the beginning would be $33,333.33. Okay, part B says, in 5 years' time, he sells the artwork for $50,000. After he repays his loan, how much profit will he have made? Okay, so he's going to borrow $33,333 to buy this artwork, right? But then later on, 5 years down the track, he's going to sell it for $50,000. So our job is to work out, well, how much profit would he actually make on that? First thing we have to do is work out, well, over 5 years, if he was making quarterly repayments on this loan, he would have made 20 payments in total, because 5 times 4 gives you 20 payments, 5 lots of 4 quarters. All right, so he's made 20 payments in total. We knew that the payment from the question was $500, so he's really making 20 payments of $500. But obviously, as well as paying off this interest over time, he's also just got the amount of money he borrowed at the beginning. So the total amount repaid is what he borrowed at the beginning, which is $33,333, plus the total interest, which is 20 lots of $500, because remember that these repayments were interest-only payments. So every one of these $500 payments was just going towards interest, and he made 20 of them. All right, so the total amount that he repaid at the end of the loan was $43,333.33. That's how much money he had to give back to the bank. And of course, his profit comes from, well, he generated $50,000 by selling the artwork. So the difference between those two numbers, $50,000 minus what he had to pay back to the bank, which in total was $43,333, leaves him with $6,666.67 profit. So not a bad payday for Pete from buying and selling some artwork.